Hi, my name is Dan, and I'm here to walk through with you the 2018 Washington State Energy Code residential components on build tight and ventilate right options. You could also call this air leakage and whole house ventilation in the 2018 Washington State Residential Energy Code, and including the 2018 Washington version of the International Mechanical Code. So we've all heard this concept, perhaps build tight and ventilate right, but do we have the approaches that we need to make sure that these are cost competitive, bring good sales opportunities in, and are beneficial to the resiliency of the home, the comfort and indoor environmental quality? In this training, we'll briefly cover why it's important to use ventilation in these homes. We're really going to move on to the common strategies for how we get there. This includes common strategies for exhaust ventilation, balanced ventilation, supply ventilation, and as well as many tips and tricks along the way to help you make it work. My name again is Dan Wildenhouse. I'm a technical advisor and industry liaison for Better Built Northwest, and I'm happy to be here with you today.
In this first section, we really are going to build some background. So by that, I mean, we'll talk and go through some definitions and talk about some jargon and lingo that is commonly used. We'll look at what the codes are actually asking us to do. And then we'll kind of start putting this together and put some of the why to it. After this section, we'll jump into air sealing. In other words, the next step after the background will be building tight.
So why should we build right? Well, I mean, of course, you can cheekily say because code says so. But I would really look at the right-hand side of the screen, and it's so that we can deliver predictable performance. We've been accidentally building homes tighter over the years just by doing things like moving away from skip sheathing to sheet product, going away from lath and plaster to drywall, going away from balloon framing to true stick framing. Just a ton of the decisions that we've made over the years with better products have naturally started tightening up our home. So now we're at the place of let's intentionally do the rest of the work. Let's make sure that we disconnect our home from the places we don't want to get air from. And then let's make sure that we then combine this with a ventilation approach so that we know where our air is coming from or going to, and we can control moisture and resiliency in our buildings. When you do those two things together, you get predictable performance. And believe it or not, I know it doesn't always feel this way, but the energy codes, mechanical codes, residential codes, and all the other codes that we utilize are designed with science and physics as their backbone. Whenever possible, a lot of work is done to make sure that these work together, all towards this goal of being buildable, being as affordable as is reasonable, and to deliver predictable performance for the people who buy these homes. So what the heck does code say? The Washington State Energy Code, under the prescriptive requirements, has a minimum of 5 air changes per hour, tested at 50 pascals. And don't worry, we'll get into that in just a little bit. But there are some additional options you could do, right? From the table 406.3, when you're looking at your additional measures, you could select one with 3 air changes per hour. That is going to require a little bit better ventilation. Option 2.2, 2 air changes per hour, is now going to require balanced ventilation with heat recovery, all the way down to 0.6 air changes per hour, which is going to require an ultra high efficiency heat or energy recovery ventilator. How does that compare to some of the other codes that you may be experiencing as a builder? Let's say, for instance, you build also in Idaho, or you build in other parts of the country. Then you're probably familiar with the IECC, or the International Energy Conservation Code. For climate zones 4 and 5, that is basically describing Washington State, their target is 3 air changes per hour. But perhaps you build in Oregon, and you may know they have a new code as well, the 2021 Oregon Residential Specialty Code. And there they give you an option. You can either fill out a fairly detailed prescriptive checklist, which includes ensuring that all top plates between any conditioned and unconditioned space, like for instance, between the top floor of your home and the attic, that those are properly sealed. Or you can do a blower door test, a building tightness test, and achieve 4 air changes per hour. So you can see that there's a little difference here. Why is Washington State 5 a little bit higher? It's not because we don't believe builders can hit 3 or 4. It's so that we can give you the opportunity to take points or credits, if you will, from this additional credit table for hitting these more stringent requirements.
If you've been building in Washington for a while, you know that we've had a requirement, at least since 2012, on building tightness. Actually, it goes back further than that, but it was prescriptive in the early days. And there are some minor changes to the prescriptive base requirement in the Washington State Energy Code for building an airtight home. The base number of 5 air changes per hour has not changed. That was true in the 2015 Washington State Energy Code. What has changed is how the people who do that test, how they calculate the volume of the home. Previously, if you just used a standard air changes per hour calculation, bigger homes had a slightly easier time meeting that 5 air changes per hour number than did smaller homes. And that didn't feel quite right to us. It doesn't really sit all right. And that has to do with the shape and size of homes and the dimensionality. In other words, the difference between conditioned floor area and volume. So when we look at something like that, we want to kind of get it a little bit corrected so that small homes, medium homes, and large homes all kind of have the same chance with the same degree of air sealing to meet the ventilation or meet the tightness requirements. So with that, a small change has been made to how they do the calculation. Basically, they force a uniform ceiling height to be adopted, and that really helps level this out a bit. So you keep hearing me say tight homes. You know, what do we really mean by tight homes? Do we mean living inside of a bubble? Well, not really. I mean, let's be honest. What we really mean here are homes that are tighter than 3 air changes per hour. And that aligns pretty well with one of the options in the energy credit section in table 406.3 of the Washington State Energy Code. Option 2.1 gives you a half a credit in single family or a full credit in multifamily if you can get the home to 3 air changes per hour and make sure that your ventilation system uses Energy Star rated fans. So again, for what we're talking about in this presentation, we're going to refer to tight homes as those that are 3 air changes per hour or less. Now you're probably saying, Dan, why are you really focused on the number 3? Didn't you just tell me a 5 is the prescriptive minimum? Yes, that is true. But if you've had any experience building in Washington and you've spent any time with our new code, you'll know that the volume of additional credits that you need to get from table 406.3 has increased a fair amount. And that pretty much so means you're going to need to make one selection in each category. So you're going to have to take probably one approach under air leakage control and efficient ventilation options. And the most common, popular, and lowest cost option is this first one, 2.1, getting the house to 3 air changes per hour in terms of tightness, and then doing whole house mechanical ventilation with Energy Star rated fans. In that concept, it's not specific. You can choose whichever type of ventilation strategy you would like.
Next, we're going to jump into the air sealing component. This can also be thought of as the air barrier details in the Washington State Energy Code. So with that, let's jump into the goods. One of the critical things to understand, just even to hit our prescriptive target of 5 air changes per hour, there's some really good guidance in the Washington State Energy Code and in the IECC, and it's this table R402, the air barrier and insulation installation table. That's the top half of our screen. And what it does, it gives you the component, and it tells you what the air barrier criteria is and the insulation criteria in order for those to work together. You can also alternatively use something like the Energy Star Rater Field Checklist, which basically covers all of the same, but more in a traditional checklist format. And here I'm just looking at the fully aligned air barrier section of the Energy Star checklist. Either one is going to be a really good way to get there. And I'm going to show you a couple of examples of what we mean by backing and blocking. And then later we'll get into the part where we talk about caulking.
So as I said before, in the 2018 Washington State Energy Code, you are now required to get more credits than you had to in the previous code cycle, which basically means you're going to need to get some points from every category. So here we're looking at the air leakage control and ventilation, and efficient ventilation category. And you'll notice there's 4 different options. We're going to go through these kind of one at a time and talk about some of the ways to achieve each of these as we go through it. So this is table 406.3 and the Washington State Energy Code, and it will outline all of these. We're going to focus right now just on section 2, options 2.1 through 2.4. So the first credit we're going to talk about is option 2.1. It's worth a half a credit in single family. And this is by far and away the most common, popular, and cost-effective measure in this category. We're talking about getting the home to 3 air changes per hour from 5, which was the prescriptive, and we'll talk a little bit about how to get there, and then using an Energy Star rated fan or fans dedicated to whole house ventilation. This particular credit does not really have any specific required way to get there, meaning you can use exhaust only, supply and exhaust, or a packaged balance system such as a heat recovery ventilator. Have no fear. We're going to start with how to get to 3 air changes per hour. Then a little bit later, we'll talk about those different options, and we'll start with the most cost-effective ways to meet the whole house ventilation requirement. So how do we get to 3 air changes per hour from 5? Well, within the International Energy Code or the Washington State Energy Code, there's actually kind of a checklist that walks you through some of the critical places to focus air sealing. There are other checklists that exist out there as well, and we kind of refer to this as the standard caulk and seal method, right? Using things like a caulking gun, single part spray foam, potentially 2-part spray foam. This is really that approach. And if you follow one of these checklists, on the left side of your screen, you see the air barrier and sealing checklist from the Energy Trust of Oregon. Very great checklist, available for free online. On the right-hand side, you have the National Radar Field Checklist for the Energy Star Certified Homes program. And you scroll down a little bit past thermal bridging to section 4, and you get to the air sealing details. A very similar checklist, but really this is an attention to detail kind of project. The checklist can only get you so far. There's actually a few contractors in a couple of jurisdictions. I'll just give one example that I've heard not too long ago. In Tri-Cities, a contractor who, for a fixed price based on the size of your home, can guarantee that he will get all of your homes to 3 air changes per hour. That's pretty cool, but he's doing it with really good attention to detail and the appropriate materials. So let's talk a little bit more about what that looks like.
I just mentioned that Energy Star checklist. I just blew it up a little bit so you can see it a little bit more clearly here. These are some details specific to the air sealing or the standard caulk and seal components. To get to 5 or even down to 3, it's really attention to detail with these standard things that's going to make it work. Again, you can use any of those checklists we've identified. I just wanted to give you a chance to see one a little bit more close up and see what kind of items they're identifying that you should focus on.
So a big part of this is education and communication with your key trades, right? So who are the key trades that really matter at getting a house tight? Well, you can take a look at a lot of the critical air leakage places here. There are things that impact HVAC, certainly framing, insulation, maybe even electrical and plumbing. It really depends on where the holes are. This happens to be a poster available on Better Built Northwest called the Thermal Enclosure Best Practices, something you can download, and you can include it in every scope of work that you have for your trades. Making sure that, hey, if you are touching my envelope, right, this pink line around this house, if anything you're doing is going to penetrate that or touch it, you need to take some responsibility for making sure that all gaps, cracks, and holes are properly sealed. At the end of the day, you'll have to have one trade that ultimately is responsible for this, and either that trade or another who's responsible for testing to make sure it matters. So start by thinking through, who do you need to educate? Who needs to have the right scope of work to make sure that this doesn't get passed? And do you have good resources, something like this poster or the checklist we saw on the previous slide that you could use to get people there? Next, I'm going to show you what's something that's growing in popularity in the Northwest as a tool to help you. And that tool is using a sill sealer product, right? Pretty darn inexpensive, something we typically put under a sill plate as it rests on our concrete foundation. You can cut this in half and staple it up to all of your top plates and all of your vertical intersections of interior and exterior walls, and it works great as a gasket. You do need to make sure that your drywallers are instructed of what this is and why it's there so they don't rip it off. And they also may want to learn a little bit better techniques at tilting drywall into place as opposed to sliding it up. If you slide it up, it can roll up the gasket. And you can see the picture on the far lower right. This is a top-down view of a top plate, and you can see a little bit of that gasket sticking up. And that's how we know it really got a good seal. And if you're wondering, how do we know that this really works? Well, let's take a look at how we know. Now, before we actually look specifically at the top plate gasket, I also wanted to bring up something else that can be done. We're starting to enter a realm of double benefit for a single measure. You may be familiar with the term BIBS. It stands for blown in bat system, right? BIBS is actually a proprietary term for a specific manufacturer, but a blown in blanket or blown in bat is kind of a common approach using fiberglass or cellulose, and they basically net and blow the walls. Why are we bringing this up? Well, that seems kind of odd. We did a study a number of years ago with Energy Trust of Oregon where we looked at, would this make a house tighter, blowing in the bibs? It's interesting because we did that right on the heels of another study of, do those top plate gaskets actually tighten up a home? So in the next slide, we're going to look at the results of both of those case studies. But I just want to point this out. Doing this with bibs, not only do you get potentially a tighter home, you get what's referred to as grade 1 insulation, meaning the insulation is graded as a perfect install, as compared to putting bats into place where you may not get graded that way. And you typically get an R23 out of a 2x6 wall instead of an R21, at least in the cavities where the insulation is. So this can impact your overall U value for the building or the R value of your wall assembly. So that could be helpful depending on your selection for your wall choices or your other envelope choices. And you're getting a good grade of insulation, good durability, and it may tighten up the home. Let's take a look to make sure that's true. So let's take a look at the results of these two pilots that we did with Energy Trust of Oregon. In each case, there were about 40 homes. In this bibs versus bat, and with all cases, we tried to kind of keep one builder and look at two different types of homes. One where we actually applied either the top plate gasket or the blown in bat, and one where we did not, and tried to split that more or less evenly across these. So if you look at the top two, you'll see that if you went from no top plate gasket to a top plate gasket, on average in that pilot, we saw not quite about a full air change reduction, but about a 0.8 or 0.9 air change reduction just by putting on those top plate gaskets. So we hadn't even done the vertical intersections of interior walls to exterior walls. When you do all of that, you typically get about a full air change reduction. So if you're trying to go from 5 down to 3, right, that's a pretty good way to get there. Now, the other one we did is we looked at this blown in wall, right? So we looked at, bats versus blown in walls. And guess what? Here we saw about a full air change of difference. So isn't that interesting? We actually got more of an ACH difference when we actually did the blown in wall. So as we suspected, both of these pilots showed that you can get, somewhere between 3/4 to a full air change improvement by adopting some of these measures. Now, the size and shape of the house and other factors will definitely impact this. So these are not universal numbers, but it is interesting to show that there are some pretty common low-cost practices that may have multiple benefits to you that are, again, cost-effective and are really going to help you reduce your air leakage. Now, what if you either want or need more credits out of this section? You could go to option 2.2, where now we're getting down to 2 air changes per hour, and we're putting in at least a minimum efficiency heat recovery or energy recovery ventilator. Don't worry, we'll go much more into HRVs and ERVs a little bit later in this presentation and an entire other presentation just focused on them. So let's take a look at ways that we might get down to 2 air changes per hour. Getting down to 2 air changes per hour, really, it's kind of like, I've heard it said, it's kind of like doing airtight drywall on steroids. It is being very intentional about every possible intersection and every possible penetration. even then, it can be really challenging. So some people will choose to take some other options, such as experimenting with multiple air barriers within a wall, or moving ducts inside. Those types of strategies can really help you on top of what we already talked about to get us down to 3. And again, sometimes there are some good tools out there. So here's another poster available on betterbuiltnorthwest.com, and you can just type in the thermal enclosure, efficient walls, and air tightness. And this goes into even more detail about really good ways to ensure you can approach this 2 air changes per hour. Again, getting to 2 from 3, it's really just taking it to the next level in terms of attention to detail, proper use of materials, and proper training and education for all of your trades. If you're going to do this, we do recommend at these type of levels, don't just have your existing insulator do your blower door test. You really do want to have a third party when you're going to, it's not mandatory, but very highly recommended, because those people can actually help you pinpoint where it is that you're having problems. They can use theater smoke and infrared cameras and differential pressure testing to help you zero in on where your problem areas are. So it's well worth a little bit of cost to make sure if you're shooting for something like 2 air changes per hour. The biggest questions we get asked on a pretty regular basis is, what if I'm operating in a jurisdiction that is tracking this very closely, and they very much so are letting us know that our certificate of occupancy is going to be dependent upon our blower door number, right? Because we said we were going to get to 3 or 2 air changes per hour, and they want to see us prove it. How do we make sure that we can actually get there? So it makes sense to have a plan B. So one thing you can do is, in advance, before you get going, work with each of your trades to make sure you have some instructions and mechanisms for what's going to happen if this occurrence happens. You may put some responsibility specifically on some contractors, or you may take that responsibility on yourself. Another option is you could, from the very beginning, shoot for a half credit more than you need on your credit table. Now, that's not my favorite way to do it, but I do know some contractors that are thinking that way. They say, we're just going to shoot for 6.5 credits instead of 6. That way, if we don't pass, we'll take the lesser credit and that'll still work. You can do that if you want. Probably a better option, however, is to do 2 blower door tests, or start with your first blower door test before any trim goes on. So you've got your drywall in place, do a test at that stage, because if you haven't passed then, they can still help determine where the air leaks are coming from. Is it around the can lights, the fire sprinklers, the windows, the baseboard? They can help you identify this. Now you can caulk and seal. You can call a company like Aero Barrier or a specialty contractor to come and do that work. Finally, you can, again, we talked about this already, you can really look to take some, make some choices that get you air sealing and non-air sealing credits at the same time. So things like dense packing your wall blow, moving your ducts inside conditioned space, limiting your total number of windows. Believe it or not, if you can keep it 17.5% or less glazing percentage, there's less holes in the wall. And then finding alternatives to things like recessed lighting or fire suppression systems that operate only in an attic space. The more you can look at some options like this, the better you can control that variability and have a more predictable experience. Okay, that was a lot on air sealing and getting tight, which makes sense, but now we want to talk about ventilation approaches. So now we're going to get to ventilating right.
So earlier we talked about changes to the baseline for building tight. Now we're going to look at the baseline changes to ventilating right. A couple of things are really critical here. The first is we actually look for, in order to get the ventilation components, it's not actually in the International Energy Code or the Washington State Energy Code. It's actually in the Washington State amended version of the International Mechanical Code. For multifamily or R2 buildings, this now requires balanced ventilation or balanced airflow, which means the same amount of air that comes in is the same amount of air that goes out within 10% or 5 cubic feet per minute of air. Some factors that are apply when you get to single family or R3. You're not required to do balanced ventilation, but there are some factors that will increase the minimum flow that you're required to do. If you're not balanced, again, if you don't have the same amount, so if you did an exhaust only system or a supply only system, you'll be required to put in a little bit more air. Or if it's not distributed, which typically means central ducts delivering to all the living spaces of the house, the bedrooms and the main body. Again, the flow rates are based on the 2018 International Mechanical Code. And flow rates and M&V documentation, there's a certificate we'll talk about later and actually show you how to fill that out, is required per the state codes. Your jurisdiction may actually require that to be tested by a third party as well. But the very minimum, the flow rate and the M&V documentation is going to be required by your jurisdiction.
So a little follow-up to the previous slide. Again, Washington State has higher necessary rates for whole house ventilation if you use an exhaust-only or a supply-only strategy. And again, the IRC that we use, directs us to the International Mechanical Code as opposed to an outside standard. Again, remember with low-rise multifamily, both corridor and non-corridor versions, there's a few different new things. One is, again, that requires balanced ventilation. Another thing to note, if you're familiar with ASHRAE 62.2, 2019 is the most current and up-to-date version. The IMC actually does have slightly lower rates than ASHRAE 62.2. So it really is going to behoove you to learn a little bit more about what is in the IMC. Again, we're going to cover and do some examples. What we're really going to focus on for the rest of this presentation, the examples we'll use will be single family based, but you could apply a lot of this to the R2 low-rise multifamily as well. So I mentioned this earlier, mechanical ventilation as a baseline or prescriptive code requirement is found in the IMC, and in particular the IMC with Washington amendments. This can be downloaded, again, either from the WSU Energy Code website or the Washington State Building Code Council website. In fact, Washington State Building Code Council has all the applicable codes: energy code, residential code, building code, fire code, mechanical code. All of that is available from the Washington State Building Code Council website. There's also a group called NEEC, or the Northwest Energy Efficiency Coalition, and they have some spreadsheet forms for showing compliance for the non-residential sections of the code. So if you're a builder developer watching this and you're thinking about applying this to commercial settings, NEEC, their website, Northwest Energy Efficiency Coalition, you can type that into your search engine. It will find it for you. They have some really good spreadsheets for compliance for those types of scenarios. With that, we're going to keep moving.
So the flip side, again, of the tightening the home is ventilating the home, and we want to do that correctly. And we talk about that with both local exhaust as well as which is designed to remove pollutants as they're created. So we mean the kitchen fan and the bathroom fan usually, as well as the whole house ventilation strategy. Both are necessary to maintain an overall good indoor environmental quality or reduce the risk of negative impacts to your indoor environmental quality. Some of the things really focused on with this ventilation is providing fresh filtered air, regulating RH or relative humidity, getting rid of air toxics like volatile organic chemicals, reducing the particulate count in the air, maintaining our comfort, and of course, complying with code.
One thing we talk about is putting the V back in HVAC, right? And for those who don't know, it's heating, ventilation, and air conditioning, or as a buddy of mine in Texas said, heating, venting, and cooling. Whatever works for you. But in both of those versions, ventilation is actually part of the HVAC. And wouldn't it be nice to actually have HVAC mean ventilation as well as heating and air conditioning? So there are really 4 different approaches that are acceptable in the Washington State Energy Code. And we'll go through kind of the most cost-effective options for 1, 2, and 3 here in this module. And in another one entirely, we'll go a much deeper dive into heat recovery and energy recovery. So you could use exhaust only, right? So using spot fans to vent out, you could have 1 or 2 set to run continuously, for instance, to serve your whole house ventilation requirement. You could use what's supply side ventilation, which is most typically a fresh air duct from outside being integrated into your central forced air handler if you have a heat pump or a gas furnace. That can work. Each of these has their own unique pros and cons, and we'll go through them. Or you could shoot for a balanced ventilation strategy. So again, introducing exhaust and supply in approximately equal amount really can help. Again, this is a really good solution, and this is the lowest amount of ventilation needed to be put into a single family home is achieved when you go with balanced ventilation. And don't worry, we're going to walk through several examples of how to do that math. So next, we're going to jump through each of these one at a time. First, let's talk about how much ventilation do I need? And has this changed since the 2015 Energy Code? And actually it has. So 2018 Washington State Energy Code references the 2018 Washington State Mechanical Code as the place where we want to get our ventilation requirements from. And in this, you know, it actually now has made some interesting adaptations to say, we want to require more ventilation when you're not providing it in both a balanced and distributed manner. By balanced, again, we mean the same amount coming out as going into the home, and distributed meaning being brought to the bedrooms and the main body of the house. So that's an interesting challenge, right? But we want to try it if you're just using exhaust only or supply only, you will need to do more ventilation than if you were going balanced. Likewise, if you are doing balanced but you're not distributing it everywhere, when we'll talk about spot ERVs a little bit later, you're also going to need to do more. How much more is based off of this little table that you see here. And again, don't worry, we're going to go through the math in just a couple minutes and show some examples. So let's start with the exhaust only options. So we could put in a surface mount exhaust fan, an Energy Star rated fan. That is a part of that requirement for 3.1, by the way, as it must be Energy Star. Or rather 2.1, the 3 air changes per hour option. So we could go with something like this. By the way, some of the benefits for Energy Star fans are not just that they use less energy. They're typically rated for between 10,000 and 20,000 hours of continuous operation, and they're rated to be quieter. So if you're going to use an exhaust-only strategy, meaning you're basically going to leave an exhaust fan running all the time or on and off a lot throughout the day, you want the quietest fan that's cost-effective to buy so people don't turn it off, right? So these requirements, using an Energy Star piece of equipment is a really good way to think about it. Use the least amount of energy to do it. Have a good rating for long amount of hours that it can run continuous, and be able to do its job pretty quietly, right? So that's kind of where we want to look at with this. The DOE actually says, so one of the interesting things people sometimes complain about with exhaust only is it depressurizes the house, right? Sucks air out, so new air has to come in from new places. We talked earlier about if you do a good job of sealing off your attic, your crawl space, and your garage, then you're left with, hopefully more holes through things like your walls. And the DOE looked at this and said, and your average new construction home, just the structure itself, the walls, the ceiling, the floor, acts like a MERV 6 filter by its own. So if you are sucking air out of the house and new air has to come in, the US DOE has done some study work and said that's about like a MERV 6 home. Our friends at Panasonic have also done the math and report that with a good Energy Star rated fan, it may only cost about $5 a year, just in terms of fan energy only. We're not talking about the energy to heat or cool the replacement air, but for the fan energy, it's about $5 a year to turn on this exhaust fan and let it run. Building science would tell us that, we would need it would need to be 20 degrees colder outside than it is inside of our home for Mother Nature to get us, even part of the way towards where these fans can get. So as you can imagine, a lot of the year in the Northwest, it's not more than 20 degrees colder. So this goes back to that other slide with how much ventilation do I need? Basically, you almost always need some ventilation. Back to Panasonic, they also recommend going to balanced ventilation, even though they sell the exhaust fans. They do admit really tight homes and really big homes, it makes more sense to do balanced ventilation in those strategies. In really big homes, it's because even though they may be tight, 3 air changes per hour for a big home is still a lot of CFM. So a single exhaust fan may not actually create that negative pressure that you wanted to draw air in from the areas you want. And for really tight homes, whether it's because of the size of the building or because you were really successful at air sealing, it turns out in a really, really tight home, you just don't get what you think you're going to get out of an exhaust system in those, because it can actually make the fan work too hard and creates too much of a negative pressure and doesn't really pull the air from where you want. So in tight homes, in really big homes, even the folks at companies like Panasonic admit best probably to think about balanced ventilation. So it does have an application, exhaust only, and we'll look at some options for that in a couple minutes. Now, another component, and this is actually a truism of all types of ventilation systems, but we're going to use the example of exhaust only right now, is you want to have the right controller. And it doesn't mean it has to be the same brand as your fan. It just means it has to work well with it. Some of the controllers that you see on this screen here, particularly the one on the far left and the 2 on the right, those actually have the ability to set where they can run continuously at a low rate in the background, and then still have the ability, you push the button or twist the knob or the dial, and it can go to a higher speed for when you need spot ventilation. So in your bathroom, maybe it's running, you have 2 fans and they're each running 30 CFM in background mode. You take a shower, you hit that button, twist that dial, it boosts up to 80 CFM, gets that fog off the mirror, gets the humidity out of the room pretty quickly. So those are pretty cool. The one that looks like a dial, kind of the middle left there, that has the on-off auto rocker switch at the bottom, that is strictly a 24-hour timer. You have to set it how often you want it to come on and off. It's very rudimentary. It's inexpensive. It's easy to look at and to commission. The downside, it's also easy for a homeowner to turn it off. So the ones where it works in the background are probably your slightly better bet, probably worth a little bit more money when thinking about our control strategy. Now, similar to the exhaust only, this is an approach that we've been talking about and working with builders on in the Pacific Northwest, gosh, for 15 years now, called the supply only strategy. So in this case, on the left-hand picture, that is a duct that goes to the outside, and its only job is to pull in fresh air into the central air handler so that either intermittently or continuously, that central air handler can run at a pretty low speed and bring in some outside air, distribute it throughout the house. And it's typically going to come with a series of controls, and the Honeywell is a popular one, but again, we're brand agnostic or non-denominational, if you will. Pick the brand that works for you, but you want to have a good control strategy that works with this. Some of the challenges with supply only, it can be hard to commission this. Right? If that's really high up on a wall, it's going to be hard for someone to get up there and measure that airflow rate. So do you really know how much air you're moving? Also, sometimes does grandma really want cold air blowing on her head, which is the sensation she can get if this is just pulling in outdoor air and moving air around, and it's not a call for heating, for instance, in the wintertime. Grandma gets cold air on her head. That can be a bit challenging. Here's a different way to look at that same design, right? So we're bringing in fresh outside air. We've got that motorized damper. It controls and opens based on a timer. We also have a manual damper, so when you commission it, you can adjust how much air is going to come through. And one of the things you'll notice here, guess what? This at least has good distribution. It's not balanced if it's just supply only, but at least it's capable of pushing air into all the bedrooms. So that's a pretty big difference from the exhaust only strategy, which was neither distributed nor balanced. This is at least distributed. Again, we're going to go through some examples, but the math would tell me that I have to multiply my base ventilation rate by 1.25 if I'm not balanced, but I am distributed. Whereas if I'm neither, I have to multiply it by 1.5. You can start to see some of the choices. The other benefit here is, you can put this outside air intake. You as a builder get to choose where that is. So you can choose better indoor air quality locations, right? To make sure that people know where their fresh air is coming from. That's a pretty nice benefit. So supply only does have some nice benefits to it. It has some challenges as well, and we'll get into those in just a second. So one of the challenges with supply side ventilation, I'm going to go through some animations here, right? So we have supply air coming in to the return side, pushing air in. This actually positively pressurizes the house, right? So you're actually forcing air out through every gap and crack, as opposed to the exhaust fan sucked air in through every gap and crack. This one forces air out through every gap and crack. And imagine what happens if you push warm, sort of moist air from the main body of the house into an attic when it's 40 degrees outside, or into a wall on the north side of the building that never gets sun. That potentially can be problematic. So I promised you we'd look at some low-cost solutions to meeting the Washington State Energy Code and the Washington State Mechanical Code, right? So the first option is to use exhaust only. It's highly recommended or required, depending on which level you're at, to use Energy Star rated equipment. Again, remember, that's going to get you a lot of different benefits, not just energy use. Running it continuous is a better bet than running it intermittently. We'll go through that math in a little bit. If you do run it intermittently, you want to probably run it 20 minutes out of every hour at least, or 33% of the time. That's probably your minimum there. On the right, you see some of the criteria that they use in terms of efficiency for Energy Star certified fans. Again, it's not just the efficiency that matters. It's also the rated for continuous operation and the low noise. But this is all working together. So this is your best low-cost option.
So with that low-cost solution, you've got a couple different options of which exhaust fan you might want to use. And depending on how much airflow you need, you may actually want to have multiple exhaust fans moving air at a predetermined either intermittent rate, meaning on and off, or more likely continuously in order to meet your airflow requirements.
Your next lowest cost option would be the supply side only. So we integrate a fresh air duct into that central air handler by tying it into the return plenum. We do recommend you only do this with ECM motors of 2.2 or higher. The federal minimum standard requires that all fans be, or all central air handlers be ECM or electrically commutated, but that allows for some things that are not ECM 2.2 or 2.3 or 2.4. The higher the rating on the ECM in that numbering, typically the more efficient it is and the better capability it has to run at very low speeds. And this can provide some really decent comfort and energy use if you set to run at that lowest airspeed. Now, one of the things, if you're doing this, you definitely want to check with your jurisdiction, because some jurisdictions may also require that you show what's called a sequence of operation for both the HVAC system and controls, as well as how you commissioned your ventilation system. So you may need to have a sequence of operations for HVAC systems present and turned into a checklist for your jurisdiction. Just be aware of that if you're going with this solution.
Looking at the supply side, here you can see that, again, we've got that pipe of air coming in to the return side of the central air handler and then being distributed throughout the house. If that were the only thing that that's running continuously or is designed to meet your whole house ventilation requirement, that is called supply side ventilation. It could also be paired, however, with any of those exhaust fans to create a balanced ventilation strategy.
So what is our lowest cost balanced ventilation approach? Well, guess what? We're basically taking the low cost exhaust only and combining it with a low cost supply only. So here we're kind of matching a designated continuous fan for exhaust. And we're talking about a fan or a duct bringing fresh air in to the return side of our central air handler. And we want to make sure that we commission them so it's about the same airflow. If the house needs 60 CFM, then we have a exhaust fan that's either rated to run at 60 CFM continuous, or maybe a couple of them at 30 each. And then we commission that the fresh air coming in when the air handler is running on low speed is around 60 CFM. And voila, there we go. We have a pretty decent balanced ventilation strategy here. You can do this intermittently, meaning it comes on and it comes off. But we're going to go through again. I've talked about that math. We want to show you that math because you'll pretty quickly realize the size of fans and the speed that you need to run your central air handler may make that not really the kind of solution you're looking for pretty quickly. If you can figure out a way to do this continuously, again, with an Energy Star exhaust fan, an ECM 2.2 or higher central air handler motor, commissioning them to be within 10% of the supply and exhaust, and then run them continuous, that is your best low-cost bet for balanced ventilation. You get many of the benefits of the other two low-cost strategies. You know where your exhaust air is going. You know where your fresh air is coming in. You're not worried about pushing air into walls and into attics through positive pressurization. You're not worried about sucking air in through crawl spaces and attics with negative, and garages through negative pressurization. The homeowner is in really good control of the indoor air quality. The only thing here is, will they keep it on? So again, using high quality equipment with an ECM motor, that's your best bet, allowing it to run at its lowest speed possible so grandma doesn't get cold air blowing directly on her. People don't turn it off because they don't understand. That whole process, it's all of that together is what it takes to make a low-cost balanced ventilation approach work. And finally, there is this option of heat recovery and energy recovery ventilators. We are going to talk a little bit about this in this session, but again, there's an entire another training just really going to go deep into HRVs and ERVs. But let's talk about them right off the bat. First off, on cost, there are actually a number of these that we've seen for sale both online and through local distributors that meet anywhere from the minimum to the maximum efficiency range for under $1,200. So when someone says this is a $3,000 piece of equipment, perhaps when you combine all the ductwork, the controls, the piece of equipment, and the installation, perhaps it's approaching that. But if you work with your distributor, you showcase the needs that you have, you learn to do the math, and look on places like the Heating and Ventilation Institute website to determine what size of equipment you need. If you are willing to do a little bit of that work or have your HVAC trade do it for you, you can find a relatively cost-effective way to use heat recovery or energy recovery ventilators. So these are great for a lot of different reasons. We would say that there are some people who say, great, if I'm sucking air out of my bathrooms, I don't need a bathroom fan anymore. I can save money that way. We actually discourage that thinking. You do still want a bath fan. As it turns out, homeowners like to see the fog go off their mirror quickly. And a little, port hooked to an HRV that is moving, 7 CFM to 15 CFM continuous out of your bathroom, that neither meets the IMC requirements for spot ventilation, nor will it very quickly remove that moisture. So think it through. You may still want to put those in. But this does have a lot of benefits. It meets the balance requirement. Depending on how you run the ductwork, it meets the distributed requirement. So it can be a really good option. So here we're starting with the whole house ventilation strategy using an exhaust fan only, all right? So the Washington State version of the International Mechanical Code has this formula, 7.5 cubic feet per minute for every person that's in the house, plus an additional kicker of 1% of the floor area translated to cubic feet per minute. So if we did that math, let's say we have a 2,500 square foot, 3-bedroom home. 1% of 2,500 is 25 CFM. A 3-bedroom home is assumed to have 4 people. So you add 25 plus 30 and you get 55 CFM if you ran it continuous. But remember I said earlier, there's a benefit to doing balanced ventilation. This is where this kicks in. For a home that's neither balanced nor distributed, you have to multiply this with this ventilation adjustment factor, right? And it's 1.5 for something that's neither balanced nor distributed. So all of the sudden, a fan that needed to be 55 CFM continuous now needs to be 83 CFM continuous. You see the challenge here? By choosing to go with exhaust only, you now have to do more ventilation. So it changes the size of equipment you buy. You have to decide, am I going to achieve that with 1 fan, 2 fans, 3 fans? it does make your life a little bit more complicated. So what if I compare that to, say, doing a balanced ventilation system, right? Here, again, I do that same size house, I do the math, and it's 55 CFM continuous. But because it's balanced and distributed, in this case with a heat recovery ventilator, I don't need to multiply that by anything. So I can afford to get an HRV or a balanced ventilation strategy where an HRV running at medium speed, or central air handler on low speed with a fresh air duct and paired with an exhaust fan, I can do this and maintain 55 CFM and don't have to worry about supersizing anything. All this said, even though balanced ventilation requires a lower rate in the code, tight homes still benefit from maintaining a higher rate of ventilation. So when you're getting to those homes under 3, even though code says you don't need to put in more ventilation, it's still a good benefit. So especially if you're using heat recovery ventilation, since there's not much of an energy penalty for putting more air movement through, you might as well. Just a good best practice to consider. Now, part of what is included is that these systems are supposed to be commissioned. In other words, measurement and verification to show that they're actually moving the air that they're supposed to move. If you put in a piece of equipment and it actually doesn't work, then you spent money on something that actually doesn't deliver for your end homeowner, and that will typically lead to anything from moisture problems to poor referrals. Let's just take care of this. I did mention earlier, some jurisdictions will require a commissioning report on this, some will not. Probably a best practice is to get into the habit of performing the commissioning and generating a commissioning report for every home that you work in. That way, regardless of what jurisdiction you're in, you have this process built into your timeline and into your cost. So it's something that doesn't feel like an extra just for one place. The best and easiest to reference commissioning standards that currently exist out there are the ANSI ResNet ICC 380 2019 standards. And they give some pretty decent guidance on commissioning for ventilation systems, as well as the blower door test and the duct leakage test that are also part of the energy code. So it's a handy document to have. Your HVAC contractor or home energy rater who does your performance testing should have a copy of that on hand. Now, I mentioned this earlier, a ventilation system that gets turned off is not actually a ventilation system. It's just a switch that nobody likes to turn on. So one of the things that can be done is you can build a homeowner operation manual. As homes get more and more complex, it's kind of funny to think about, I could buy literally an old Blu-ray player, and it's going to come with a 93-page manual in multiple languages. And yet I can spend $420,000 on a brand new home, and it doesn't come with the manual. Does that make sense? Well, certainly not as we start putting more and more high-tech solutions into our homes. That need is getting greater and greater. So I'm not telling you to do it. I'm saying start thinking about it. In the meantime, at the very least, you probably want to find a good way to label the ventilation controls. So here are 2 examples. The one on the left is from Lawrence Berkeley National Labs. The one on the right is from the Home Ventilating Institute. In both cases, you can print these on stickers. You can choose what you want it to say. And it's just a way to communicate on some level to your homeowners. And it also protects you, that you've done your due diligence to ensure that people know what the home ventilation system is and where the controls are. Again, you may actually get some jurisdictions that begin to require this over this code cycle. So probably right now it's a recommended practice. This is a really good habit to get in and start thinking about down the road a full homeowner operation manual. At the very least, if you were to put together some sort of manual, or if you're simply going to provide some basic education to the homeowners, you at least want to get them some basics of maintenance. What are they going to need to know about their ventilation system? Most ventilation systems will have filters, whether that is a supply side or a balanced ventilation strategy, almost always will. So provide some good guidance on how to and when to clean the filters. Same with the exterior grills. If you've ever seen an intake grill on a home that's 12 years old, it will have debris and spider webs and all kinds of stuff stuck to it. So having the right size mesh and having some instruction on cleaning it is a really good idea. Also, maybe think in advance, does it make sense to have a fresh air intake hood on the roof? What's the opportunity for Mr. and Mrs. Smith or Mr. and Mrs. Lee to actually climb up there and clean that? Probably not very good. So responsible location of the intake as well as some guidance on maintenance. Cleaning the fan impellers and lubricating the bearings if necessary. We might be starting to drift into a place where a maintenance contract with an HVAC contractor makes more sense, but you can get some basics for a homeowner here. And definitely checking condensate pans and lines if they use a heat recovery ventilator, for instance. Really good maintenance tips. Again, this protects you and allows the homeowner to get that experience of the predictable performance they're looking for. So we know this feels like a lot. You know why? Because it is, right? These code changes can involve a fair amount of new things. So it's really critical that you get the right trades involved as early in the process as possible. This could be having pre-construction meetings or just having very improved and detailed scopes of work so that everyone knows what they're expected to do in order to deliver a tight home that is ventilated right. So from the building tightness and air sealing components, you definitely want your insulators, your framers, your siders, and your window and door installers all involved because they're all going to play a role typically in making sure that this house actually gets built tight. When we talk about the mechanical side for the ventilation, typically the HVAC, the plumber, and the electrician may all end up being involved. The plumber a little less so, but again, if you're running condensate drains and you're trying to tie it into another system, they need to know about that. We know that a lot of electricians currently have it in their scope of work to install the exhaust fans. You may want to split those responsibilities. Maybe the HVAC contractor is responsible for getting the correct fan and making sure it's vented properly while the electrician does the wiring component. All possible. And then the M&V and the commissioning, making sure that your house is tight enough, your ducts are tight enough, and your ventilation system is properly sized and performing correctly. A home energy rater, there's plenty of them out there. They provide a lot of additional valuable services that we won't talk about today, but they're a great trade if you don't already have one on staff to bring into your fold. They can do all of this commissioning from a third-party perspective, really helping to ensure, again, you're delivering that predictable performance. But they can also qualify you for utility programs and tax credits and many other things. If you were to do a pre-construction meeting, you'd want all of these folks there. Or again, if that's not very practical, take a look at what the scopes of work are like and the contracts are like with each of these and make changes so that it's crystal clear what roles and responsibilities each trade needs to take in order to build tight and ventilate right. All right, let's wrap this up and get you back to business.
As we wind this up today, we want to show you a couple of really great resources. There's actually a ton out there. We'll give you my contact information included, but start here. The WSU Energy Program website. This is where you're going to get the most robust current set of all the tools you need to help you be able to meet the residential portions of the Washington State Energy Code and the Washington State's version of the International Mechanical Code. Next is Better Built Northwest, and this website is a great location. It has more detailed trainings. I shouldn't say more detailed, more in-depth trainings that go above and beyond code. This is really a location to culminate all of the effort in the Northwest to build homes better than code. And then finally, the Building America Solution Center. Effectively, every piece of research that's been done over the past 20 years with the DOE's Building America program lives on this website. And there are a ton of great resources, everything from code briefs to program checklists, how to think about different building components, program checklist or disaster resistance, and a sales tool for your sales staff to help them learn how to take some of these code requirements and turn them into something that can be a sales advantage for your team.
With that, my name is Dan Wildenhouse. Again, I am the technical advisor and industry liaison for Better Built Northwest. Right there on the screen, that's my mobile number and my email address. I prefer text or email, It's just much easier for me to track who's contacting me. So if you have questions about anything I talked about in today's training, feel free to reach out to me, and I'll do my best to get back to you as soon as possible. I truly hope you had a great time with this, and I hope that you learned something. And we'll talk to you very soon. Thank you for your time.